Everybody, welcome to the lesson 5 video for Algebra 1. In this video, I'm going to be sharing with you some information about absolute values. Absolute value is a simple concept. It's not a simple concept. Uh, Actually, it's really easy to find the absolute value of a number. But the thing about absolute value is it has a background that's not quite so easy to grasp. It's not hard, but it's not as simple as it looks on its face. You're used to using absolute values to change negative numbers positive and leave positive numbers alone. In this video, we're going to talk about why we do that. But we're also going to learn something in this lesson that is sort of interesting. We're going to learn how to do addition and subtraction. Again, you pretty much know how to do addition, but we're going to be adding negative numbers, which involves absolute value a little bit. And we're going to be learning something I say throughout Algebra 1. I'm going to keep saying that all subtraction is addition. Another thing I'm going to be saying we're not going to be learning in this video, but we'll get to later, all division is actually multiplication. You'll find out what those mean as we go along. But in this video, we are going to be learning about addition of negative numbers, and we're going to learn why I keep saying that all subtraction is actually addition. All right, now let's start off by defining what an absolute value is. It's maybe not what you think the definition is. Absolute value is, and I'm going to say for a number n, I'm just going to say when I'm talking about a number n, the absolute value of that number is the distance from n to 0 on a number line. That's how I define it. Okay, so you're used to absolute value, meaning that you take the positive value of whatever value is within the absolute value symbols. But really, the reason we do that is because absolute value refers to the distance between the number and 0 on a number line. What does that look like? Well, here's what that means. If I take the absolute value of -4, I get the value 4. Anytime I take the absolute value of a negative number, I get that same number except positive. Let's take a look at why that is. This is a number line that shows from -10 to +10. When I talk about the absolute value of -4, I'm talking about the distance between -4 and 0 on a number line. Distance in this context can't be negative. I'm just talking about like the absolute distance. If I were to measure how far it is between 4 and 0, and it always comes back as a positive number, what is the distance between -4 and 0? Well, what is that distance? 1, 2, 3, 4. 4 units. That's what I'm going to say the answer is. That's why -4 gets turned into 4 when run through an absolute value, because it's the distance between -4 and 0 on the number line. It's +4. Now, what if I tried to figure out the absolute value of +4? Well, let's just slide this absolute value expression over here on our number line. So we're dealing with 0 and 4 instead. So the distance between 0 and +4 on a number line is 4. And that's going to be true for all positive numbers. For any positive real number, the distance between 0 and that positive real number is just that same number. For any negative number, the distance between that negative real number and 0 is going to be the positive version of that real number. And that's why absolute values work the way that they do. The absolute value symbols basically just change any negative number to positive, and they allow any positive number to remain positive. Hey, just one other quick thing about the absolute value symbol. The absolute value symbol counts as a grouping symbol like we learned in the previous lesson. So any expression that's within the absolute value symbol needs to be simplified first before you find the absolute value. Okay, so to get rid of the absolute value symbol, you need to simplify any expressions within that symbol. All right, let's explore this in different ways. And we're going to be talking now about addition, like I mentioned at the beginning. So we're going to be talking about how to do addition and how addition and subtraction are very, very intimately related. What if I try to find the sum of a negative number and a positive number? This is something we're going to be doing all year, so make sure you pay attention to this and really internalize what we're doing. What is -5 plus 3? Well, one way to do this is to model it using what are called algebra tiles. So for every negative integer, for every negative part of -5, I'm going to list one negative algebra tile. Each one of those is like -1, okay? So -1, -2, -3, -4. Here I have -5 algebra tiles. And then 3 is a positive integer, so I'm going to give it 3 positive tiles, 1, 2, 3. Now, to add those two, add -5 and 3, I'm going to line up these algebra tiles, and then I'm going to circle any pairs of positive negatives, because each +1 and -1 are going to obliterate each other. They're going to cause each other to disappear. So these are all adding up to 0. And what am I left with? -5 plus 3 is actually -2, because I have 2 negative tiles left over once I've obliterated all of my positives or all of my negatives, okay? So whenever you add a negative and a positive number, what's going to end up happening is one of those two is going to get completely obliterated. Either you're going to have more negative tiles than positives, and all your positives are going to get obliterated by negatives, or you're going to have more positives and negatives, and all of your negatives will get obliterated by positives. And then you just count whatever's left over, whatever didn't get obliterated, and you're left with that. Here I have -2 left over. If I were to show this on a number line, I can do that as well. To show this on a number line, I simply will have, starting at 0, I'm going to go back -5, and then from there, I'm going to go to the right 3. So when I say -5, what I mean is I'm going to go left on the number line from 0, 5 units. So I always start at 0 when I do math on the number line. We go -5. 1, 2, 3, 4, 5. Here I'm at -5. And then +3. I have to go to the right 3. 1, 2, 3. Notice I end at -2. That's exactly what I would have expected. All right, let's take a look at some more examples of this. Use algebra tiles to find the sum, then find the model each problem on a number line. We're just going to use this number line up above to do the same thing. So 4 plus a -3. Well, that means I have 4 positive tiles and 3 negative tiles. My negatives are going to get completely obliterated here because I only have 3 of those and I have 4 positives. What do I have left over when I obliterate each positive with 1 negative? I have 1 positive. So the answer to this should be 1. Let's just check that on the number line. I'm going to go to the right 4 because positive 4 comes first. 1, 2, 3, 4. But then I have to go back to the left 3. 1, 2, 3. I end at 1. 1 is the correct answer. Okay, let's take a look at another one of these right here. What about -2 minus 6? Well, here, I'm not going to obliterate any tiles because I have no positives to pair with any negatives to cancel them out. So I'm just going to make all of my tiles and then count them up. 1, 2, 3, 4, 5, 6, 7, 8. -8 is the answer of -2 plus -6. Let's take a look at what happens on the number line. -2, 1, 2 to the left. Plus -6, I have to go 6 more to the left. 1, 2, 3, 4, 5, 6. I end at -8. -8 is the correct answer. Let's take a look at one more. -7 plus +7. Well, everything gets obliterated. What do I have left over? 0. I have nothing left over because everything changes to 0. -7 plus 7 is 0. Let's check on the number line. Go to the left 7. 1, 2, 3, 4, 5, 6, 7. Here I'm at -7. And then I have to go back to the right 7. 1, 2, 3, 4, 5, 6, 7. I end at 0. 0 is the correct answer. All right, let's take a look at some statements and see if these are true or false. Some of these may be false. Keep in mind that we have to provide a counterexample if anything's false. The sum of 2 positive numbers is always positive. Well, if I'm adding, we're doing the opposite of what we did here with the negatives. Let's say I only have positive tiles. I have a positive number and then another positive number. All I'm left with is positive tiles. I can't obliterate any of them. I'm going to be left with a positive number because all I have are positive tiles to count. Sum of 2 negative numbers is always negative. We have the exact same situation going on as we had here. So these are all negative tiles. Because all I'm counting are negative tiles, 2 negative numbers are always going to add to a negative. That's true. And then lastly, the sum of a positive and a negative is always negative. Well, we had a counterexample right here. Letter A is a counterexample. Here I have a positive number. being added to a negative number, and I have more positive tiles left over, so that's going to be a positive result. Sometimes the sum of a positive and negative will be negative. If I have more negative tiles than positive tiles, as we did over here, this would result in a negative result, okay? The next lesson is going to show you a shortcut that you can use to add positive and negative integers together.